Hello, my name is Kenneth Bentley Jr. This presentation is based on my IS 499 Capstone Senior Research Project at the CUNY School of Professional Studies titled Machine Learning and Business Intelligence. Business intelligence involves using technology to leverage data for the purpose of assisting businesses in making better business decisions. Emergent in the field of business intelligence is the use of machine learning by business analysts to understand customers and create value for stakeholders. The primary methods of machine learning used by analysts are supervised learning, unsupervised learning, and reinforcement learning. Business analysts choose which method to use based upon whether the data is structured or unstructured, and the business application for which the data is being analyzed. Structured data is data that is assigned to dedicated fields. In other words, the data is labeled. On the right is a spreadsheet recreation of a selection from the famous dataset created by R.A. Fisher circa 1936. He recorded the measurements of iris plants. We see that the measurements are in dedicated fields and are labeled by the class of iris plant. Structured datasets are also characterized by containing objective information. With the iris dataset, we have numerical data, the measurements of the flowers in centimeters. We also have string-based data, the names of the flowers Fisher was measuring. On the other hand, unstructured data is not clearly defined and often subjective. Examples of unstructured data are images, audio, or video. It can also include data that is text-heavy, like the comment section of a review website or social media conversation. Unstructured data can also be numeric and or string-based, but not categorized in fields. Supervised learning is used when the rows in our dataset have labels. For every input or set of inputs, there is a corresponding output that is dependent upon the inputs. We can think of the input as X variables and the outputs as Y variables. In machine learning, we use the term predictor or regressor variable to describe the inputs, and the term response variable to describe the outputs. This graphic is an example of linear regression. The linear regression algorithm fits a regression line based on the relationship between the X and Y variables. We can then use that line to predict X values that are not in our dataset. Logistic regression is a great tool for predicting the probability of discrete values. It is used in classification problems when we want to know if an item in the dataset belongs to one class or another. For example, if your dataset is comprised of patient records that contain health attributes such as height, weight, age, smoker, non-smoker, family history of diabetes, etc., and the individual records are labeled by whether the person has or does not have diabetes, we can use logistic regression to create a probability model that classifies the patient as having diabetes or not having diabetes based on the model. We can think of supervised learning as machine learning where a teacher or supervisor offers the algorithm a precise measure of its error. Unsupervised learning is based on the absence of any supervisor and therefore of absolute error measures. Unsupervised learning algorithms can be used to group data elements based on their similarity. It is up to the algorithms to decide how predictors and a dataset relate to each other. In other words, we have data that is unlabeled, and we want an algorithm that can group our data so we can label it. We call this clustering. One algorithm we can use to cluster the data is the k-means algorithm. The third major category of machine learning used for business intelligence is reinforcement learning. The previous two types of machine learning that we have discussed, supervised and unsupervised learning, have involved algorithms that find answers in structured and unstructured data sets. Reinforcement machine learning finds answers by exploring an environment with trial and error. Before we continue, let us introduce a few new terms that relate to reinforcement learning. First, we have an agent. We can say that the agent represents the algorithm that drives the learning process. Our agent learns by interacting with an environment. A simple example of an environment would be a chessboard and its pieces. The state is the current status of the environment. Continuing with our chess example, The current state would be the location of the pieces on the board, including the squares that are unoccupied by pieces. Actions are the moves performed by the agent. The process begins with the environment sending the current state to the agent. The agent then uses the algorithm to decide on an action based on the current state. The environment then returns a reward based on how the action affects the environment, along with a new current state. The reward is the feedback the environment gives to the agent for completing an action. In supervised learning, the feedback to the algorithm is decided by the teacher and is a precise measure of its error. For reinforcement learning, the reward is returned by the environment. This reward is a numeric value that is an evaluation of how well the action performed by the agent achieved a goal. This process repeats until the goal has been achieved or reaches a predefined ending. Then the algorithm creates policies based on the actions with the highest reward values. These policies are available for use by the agent for future attempts at solving the problem. There are numerous applications for machine learning in business intelligence. For example, a common use of machine learning is to create models that predict future prices for trading stocks and other commodities. Machine learning can also be used to find anomalies in data. E-commerce and financial institutions can use unsupervised machine learning to discover fraud patterns in financial transactions. Social media sites such as Facebook, Twitter, and Instagram can use supervised machine learning to analyze user sentiment and postings. After briefly discussing a few different applications of machine learning, this presentation will conclude with a real-world example of using supervised machine learning to analyze user reviews for a line of Amazon Alexa products. Recommender systems are used in numerous business applications. To start, recommender systems are used by web search engines such as Google.com, Yahoo.com, or Bing.com to offer users real-time suggestions as they type in search bars. Companies that stream media online, such as Netflix, Hulu, Spotify, or Pandora, use recommender systems to suggest content for users tailored to their preferences. The most common approaches for using reinforcement learning in recommender systems include collaborative filtering, content-based filtering, and hybrid recommender systems. For example, with collaborative filtering, recommendations are made solely based on the past interactions recorded between users and items in order to produce new recommendations. The past interactions are stored in a user item interactions matrix. Examples of the data stored in a user item interactions matrix could include ratings a user gives to a movie, time spent reading an article, or click-through rates of recommended products. With a model-based approach, the user items interactions matrix can be used to create a model where user and item representations are learned from the interactions matrix. An area where unsupervised learning can create business value is fraud detection, especially in e-commerce. According to a survey done by Statista, revenue from e-commerce in the United States amounted to $431.6 billion in 2020, and is projected to increase to $563.4 billion by 2025. As revenue grows, losses attributed to fraud grows as well. One of the most common forms of e-commerce fraud is the use of lost or stolen credit cards for transactions. Unsupervised machine learning can be an efficient way to classify transactions as fraudulent. This can be done by using algorithms such as k-means clustering to group the data. Once the inputs in the data are grouped, the clusters can be analyzed and then labeled as fraudulent or non-fraudulent behavior. Businesses can create value by analyzing trends in past data to predict future outcomes. For example, businesses can improve the efficiency of their supply chains by predicting demand for their products. Businesses can also create value by analyzing marketing trends and is used to predict future sales for managerial accounting purposes. One method to predict these outcomes is time series forecasting. A time series is a type of data that measures how things change over time. An example of a time series data set could be the total number of sales from a coffee shop each day. By collecting this data, supervised machine learning can be used to train a model that can predict future sales. The X or predictor value would be the time data, such as a date. The Y or response value would be the number of sales. Using the sliding window statistical method, we can then convert the time series data and leverage standard linear and nonlinear machine learning methods to model the dataset. The datasets are not limited to one observation per data point. Multivariate time series include more than one historical variable observed at each time step. Another business application of supervised learning is sentiment analysis. Businesses often use sentiment analysis to determine if posts from social media or reviews given by users on websites are positive or negative. This analysis can offer businesses more insights than mere numerical ratings when users give products 1 star for a negative rating or 5 stars for a positive rating. To demonstrate the use of supervised learning for sentiment analysis, I used a dataset of reviews for variations of Amazon Alexa products. Included in the dataset are comments from customers, ratings, dates of reviews, feedback, and the variations of the products being reviewed. The feedback field is an interpretation of the sentiment in the review. A feedback value of 0 indicates a negative review, and a feedback value of 1 indicates a positive review. We will use this feedback value as a label for our data. Business analysts will often begin by exploring the raw data to gain insights for later interpretation. I have included a link to my Tableau public site in the discussion board so that you can discover insights on your own. My primary takeaway from exploring the dataset is that the overwhelming number of reviews were positive. This may affect the accuracy of the model in predicting negative reviews from words in the comments section. Once we have our data, our next step is to perform data wrangling and feature extraction to convert the dataset into a more usable form for use by the algorithm. First, we use the getDummies function from the pandas package in Python to convert our categorical column of variation into separate indicator columns with 1s and 0s. Next, we use the feature extraction function from the sklearn package on the strings in the text review column to convert the words into a matrix of token columns. We are basically creating a matrix with a count of the words used in a particular review. Each unique word is assigned a column, and the rows contain 1 to 0 indicating the presence or absence of the word in a particular review. We then use the train test split function to split our data into a training set and a testing set. In the case of this example, I used a training size of 80% of the sample data, with the remaining 20% used to test the model. The algorithm I used for this example is the random forest classifier algorithm. The algorithm creates a forest of decision trees that can be used to determine if a combination of inputs will result in an action. The Python code and dataset for this example can be found at my GitHub site. A link is placed on the discussion board for you to view. Finally, we print a classification report to review the accuracy of our model and evaluate how well the model predicted sentiment as negative or positive. The classification report for the training data is used to evaluate how well our model fit the training data. As you can see, the model was 99% accurate at fitting the data. The model also had near-perfect precision for both the negative and positive reviews. You should expect the model to be near-perfect. Otherwise, the analyst should consider further steps to prepare the data or choose a different method for analysis. For the testing data, the classification report revealed that predictions of the positive reviews had perfect recall, 100%, and high precision, 92%. However, the model was far less accurate at predicting negative reviews. Of all the negative review predictions, only 88% were correct, which is the precision, and of the total negative reviews in the data set, our model only predicted 12% of them, which is poor recall. From our earlier data exploration, we noticed that most reviews in the data set are positive. This may account for the poor predictions of negative reviews in the model. This can possibly be overcome by increasing the total size of the data set, increasing the n-estimator's value of the algorithm, which is adding more decision trees in the forest, and or conducting a more thorough feature extraction to improve the quality of the data before the data is evaluated by the algorithm. In conclusion, business analysts use machine learning to create value by providing insights into data collected by businesses. The 3 primary categories of machine learning used by business analysts are supervised learning, unsupervised learning, and reinforcement learning. Which type of machine learning a business analyst will choose largely depends upon the type of data at the disposal of the analyst and the insights the analyst wishes to gain from the data. Three algorithms that analysts use to analyze business data are regression algorithms for supervised learning, k-means clustering algorithms for unsupervised learning, and k-nearest neighbor algorithms for reinforcement learning. The sentiment analysis example showed how analysts could use supervised machine learning to gain further insights in the dataset. Supervised learning is also used to make managerial accounting decisions with time series forecasting. Unsupervised learning can be used for fraud detection in e-commerce transactions. Finally, reinforcement learning is used to predict stock prices and provide recommendations to users based on their preferences with recommender systems. The examples of how an analyst can use machine learning to create value for a business are numerous and diverse. A business analyst's ability to leverage machine learning tools has become an invaluable resource in business intelligence. This concludes my presentation. Thank you for listening.